Hello, I'm Himalaya Jain. I'm going to present our work SUBIC, a supervised structured binary code for image search. We address the problem of very large-scale image search, where for a given query, we want to find similar images from a large database. As the database is large, it is important to have compressed representation of the database images, and it should also support efficient search. So in this work, we propose to use supervised structured binary codes for image search, which we call SUBIC. Yeah. So the structured binary code is just a concatenation of one hot vectors, and compared to unstructured codes, it benefits from asymmetric search, where the query is represented by a real valued vector, and the similarity computation is just addition of few scalar values corresponding to the ones in the binary image representation. In this work, our goal is to learn to represent images with such encoding in supervised manner. So to understand how we learn, let's consider an image representation Z. We divide it into m blocks. On each block, we apply softmax to get an L1 normalized vector. And then we minimize the entropy of this vector, this code, to get one hot vector, close to one hot vector. Now, consider we apply it on a batch, and we get a one hot vectors which has low entropy, but are not using all the available bits, which can be seen in the average vector PM. And now to encourage uniform use of available bits, we increase the entropy of this average code over the batch. This gives us two interesting novel code entropy-based losses, mean entropy loss and negative batch entropy loss, which we use to encode images with the structured binary codes. So here is an example of the architecture we have used. It has our encoding layer on top of a base CNN. And to make the code useful for image representation, we train it for classification task. The encoding layer has SUBIC softmax while training. Okay. So it results on category retrieval with single domain search on SAFAR 10. We compare here with recent deep hashing approaches, and we outperform them. This shows the importance of using structured binary codes. We also do cross-domain search, where we train it on ImageNet images and test it on Pascal VOC and Caltech. And here we compare with vector quantization approaches, and we improve strongly on them. To conclude, we have proposed code entropy-based losses, which along with classification loss, we use to train our network to produce compact representation, compact structured binary codes, which we used to give state-of-the-art performance on category retrieval. To find out more, please visit our poster. Thank you.